All right, guys. So in this part, we're going to learn how to make the graphs efficient. All right, and the way we do that is by creating an Euler circuit. Okay, so what we're going to do is we're going to follow these steps it gives us, and you're going to do this next on your own. So pay attention on this. So city one, we're looking at city one. I put it twice on mine. You'll have it once on yours because you can erase and all that. So I had it twice on here because of drawing purposes, and it was originally on paper. All right, so city one has two vertices of an odd degree. All right, so again, I'm going to find those vertices, and I'll put the degree here in green. All right, so B is degree 4. We got degree 2 here. C is a degree 3. E is a degree 4, degree 2, and a degree 3 there. All right, so C and D have odd degrees. Okay. So it's not efficient. All right, we can't make an Euler circuit. We're not going to end up back where we started, going through the path only once. And there's a way we could fix this. So let's say if you're a city developer, you'd be like, hey, you know what? I can actually add some roads here and get things fixed. And I'll show you what I mean. So again, like I said, there's many applications to this, but here's one. All right, so what we're going to do is find these vertices and the shortest path between them. All right, so from C to D, okay, these are the ones we're looking at. These have the odd degrees. All right, so the shortest path between it is going to be C to E. All right, B to D. Okay, and that's going to equal 8 hours. Okay, again, remember the length of the path has nothing to do. Okay, it's all about the numbers it says. All right, so C to E here is 3 hours. Then I went from E to B. That's 3 hours. And then I went from B to D, and that was 2 hours. So if I add all that up, that's 8 hours. Okay. Now, if you look at it on the surface, say you did this, C to E, that's 3 hours, and C to E to D, okay, there that's 6. But you got to pay attention to those numbers. Yes, we did it in 2 arrows, but 3 and 6 make 9. That's not efficient. Okay, if I actually go down these different roads, these other different roads, it's going to be actually faster. Okay, so again, because the way it looks in the graph doesn't necessarily mean it's saving you time. Okay, 6 E to D may be a road that's all uphill or very windy and stuff, and you have to make all these little pivots and turns. You know, who knows why? Whatever it is, it takes 6 hours to do it. All right, and that's what we care about. Okay, so here's the paths. You may have came up with a different path, same letters, kind of maybe a different or reverse order, but C, E, B, D will be the correct path to get 8 hours, and that's the shortest distance to the 2 odd degrees. All right. Now, B says for the edge with the shortest path, put a second copy of that edge. All right, and that's what I'm doing. I'm gonna show it on the second image over here. So what I'm gonna do is I'm gonna put another copy of those things. So the shortest edge here, we're going to put an extra copy. So from C to E, I'm going to make another edge. There it is. Okay, and then from E to B, make another edge, and then B to D, another edge. All right, now these edges are going to be the same distance or same time to plow them. All right, so what that does now is if we look at the degrees of this, B is now a degree 1, 2, 3, 4, 5, 6. Oh, sorry, that's not the one we're worried about. Let's erase that. D and C were the odd degrees. So D is now a degree 4. C is now a degree 4. Okay, and I guess let's just go ahead and go through all of them. The degree 6, this would be degree 2. This one would be a degree 6. So now they're all even, which means we now, by adding those paths, we now have an Euler circuit. We're going to plow all these roads and end up back where we started. Okay, and then we're going to find that path. And what ends up going to happen is because we found the shortest path to the odd number of degrees, that's going to make it the most efficient, hands down. Okay, so now we just got to come up with that path. And for this particular city, you can follow with the letters I'm going to put down. This is what it is. So if I go A to B, B to D, F to E, E to D, D to B again, C, and of course B to D again means you're taking that other path. C, let me make sure I got all these right. F, E, D, B, C, C, E, B, I put too many C's, sorry guys. All right, so DBC, E, B, E, C, A. All right, and this is going to equal 45 hours. All right, and you will not be able to find a path more efficient than that, okay? Because what we did is you found the two shortest paths to those odd number degrees, replicated the shortest amount of time, and we're not going to beat that because that's where the inefficiency is at, okay? And we took the shortest path of that inefficiency and made it efficient.